Hello and welcome to HCI 509 Research Methods and Statistical Analysis. In this lecture, we're going to talk about the basics of experimental research. This is a shorter lecture, but it's focused on something that's rather important to research design. So the motivation here is we want to understand why experimental research can allow causal inference while descriptive and relational investigations don't. Remember, we talked about this in the last lecture. We had descriptive, which had the least power, relational, which was in the middle, and experimental, which had the additional benefit of having causal inference to look at two different factors. Another thing is we want to understand experimental research in terms of your career as an HCI expert, because running experiments is kind of part and parcel what you'll be doing as you proceed through your graduate studies and start your jobs. The better you understand it, the better you'll be able to design experiments that are meaningful and impactful. So let's talk about the components of it. The first step is to come up with a research hypothesis, which we talked about. The design of an experiment needs to have three specific components. The first are the treatments or conditions. So these are the different techniques or devices or procedures we want to compare. So an example of this might be we're going to give somebody a task to do. And one method is to have them practice. Another one is to have them watch a video showing somebody actually doing the task. These two things would be treatments because one would get the practice, whereas the other one would just watch a video. And we can see how these two things impact their performance on that task. The second is the units. So these are the objects we want to apply these experimental treatments. So typically they're human subjects with specific characteristics. So they might be people performing a job on the factory floor, or they might be people who are working in a specific situation like driving a car. Then also the assignment method. So this is how these experimental units are assigned different treatments. And this is what we'll talk about here. So there's two types of keyboards. We're familiar with the QWERTY, but there's also one called a Dvorak keyboard. So we're going to look at the difference in terms of typing speed. So there's our, that's our dependent variable. And the independent variable is the type of keyboard that we're going to use. So the treatment would be the type of keyboard, so that's our independent variable. The units would be whoever we recruit to participate in the study. And then the assignment method would be how do we choose which of the participants get which type of keyboard. So in traditional, because we have two different types of keyboards, we could just flip a coin, say heads it's QWERTY and tails it's Dvorak. It's gonna, if we have enough subjects or units, we're gonna have enough examples that the central limit theorem is going to allow a pretty much a 50-50 balance between the two. What we're going to talk about here is randomization. So what is randomization? It is the random assignment of treatments to the participants. In a totally randomized experiment, nobody is able to predict the condition to which a participant is going to be assigned. So this would be one in which even the investigators themselves won't know in advance. Flipping a coin certainly fits this because until the coin result is determined, the investigators aren't going to know whether they get the QWERTY or the Dvorak keyboard assigned. So why even bother to randomize? Why not just come up with a plan in advance? Well, the key thing here is to avoid biases. So why bother randomizing? The reason is we want to avoid biases. Now, let's just assume that we're going to test the performance of somebody using the QWERTY and then the Dvorak. And then for others, we're going to test them on the Dvorak and then the QWERTY. And we're going to see how their performance differs. So to do a fair comparison, we need to randomize the assignment of keyboards. If, for example, we start having participants use the QWERTY first and then use the Dvorak, what typically will happen is the results will be biased towards the QWERTY keyboard. The performance is really good on the QWERTY, for example, and then they use this Dvorak, which they're not familiar with, they get frustrated, and this affects their performance. On the other hand, if they start with the Dvorak and go to the QWERTY, we could say, oh, wow, these people are improving when they use the QWERTY, when it's actually not the case at all. So we have to be very careful with how we choose who uses which type of keyboard first, which treatment. So what this is going to do is this is going to control the influence of hidden factors, and it allows a clean comparison between the experiment conditions. Remember, our purpose here is to try to show causal relationship between the treatment, which is in this case either the type of keyboard they use or the order in which they use the two keyboards, and their performance. So how do we go about randomizing? So a traditional method is, like we described before, tossing a coin. It could be throwing a dice or spinning a roulette wheel or drawing balls out of an urn. So these are left for statistics textbooks or probability textbooks and aren't really used much anymore. What we do nowadays is we typically use a random digit table, which contains a bunch of random digits. So it's easy to generate. And what happens is we start anywhere and we count in either direction. So in this case, we have 5 lines and we have 5 columns. But let's just assume that we're going to do an experiment that looks at only 3 types of navigation schemes. So we have 45 different participants that we've recruited, and we need to assign one of those 3 conditions. So what we can do is we can start with the third number on the first row and count to the right for 3 numbers. Okay, so these actually are, if you look at the previous slide, the last 3 columns. So we start here with 76520, and you can see here that we apply it, and we start counting to the right. And then we come up with these 3 numbers on that first row, and this allows us to determine an order. So for example, since the first one is the largest, this would correspond to condition 3. So the first person's going to get condition 3. The next person's going to get condition 1 because it's the smallest. And then the next person's going to get condition 2. So you can see here there's a random assignment that neither the experimenter nor the participant can predict in advance. Now there's a lot of randomization software tools now because it's such an easy thing to do, but using a random generated table is not so user-friendly. So there's a number of software resources available. So this one I think is randomization.com, so it's free to use. I suggest using one of these. The nice thing about using randomization is it eliminates the bias towards one particular treatment over another. So there's other ways to do this in some of the software packages, such as SAS and SPSS. So when we randomize experimental conditions, one way is counterbalancing. So we want to look at successive conditions. So we talked a little bit about QWERTY and the Dvorak keyboards, and we have a task where they perform one and then the other, and we're trying to determine the order. So this would be a successive condition. We could have something where we have participants watch a video and then do some kind of practice, and then maybe have a example where they're not watching a video, but they're actually watching another person participate in it. So these could be 3 different conditions, and we can change the order in which they do them. So let's take a look at some recognition software to generate text documents. So there's 9 different tasks on different days. So each task, the participant composed a text document in response to one of 9 predefined scenarios. So we need to randomize the order of the scenarios so that the characteristics of the scenarios could be a factor that influenced the result. So we need to randomize the order of the scenarios because we don't want the characteristics of the scenarios to become a factor that influences the results. So that would be a hidden factor we want to try to avoid. One way to do this when we have these different successive treatments is a Latin square design. Now, if you look down at the bottom, you see that there's 4 values, 4 rows, and 4 columns. And you notice that any one letter doesn't repeat itself across a row or down a column. So we use this to rotate the sequence of treatments or conditions. Each letter could represent a condition. And you can see here that each condition or treatment is given in a slightly different order. Each row represents a sequence of 4 conditions to which one person could be randomly assigned. So each person or unit is assigned a sequence or a row. And the order in which those 4 treatments are done differs depending on which sequence is given. Thank you, and I hope this has been informative, and I look forward to seeing you next time.